Hello and welcome to our little run through of the geometry quiz that you would have taken on Thursday. Wanted to have you see how these problems were worked out. Again, these are very similar to the things that you're going to see on your test next week. Problems 1, 2, and 3 we're just cross multiplying. Nothing too exciting on this one. 9x is equal to 21 times 15, which is 315. And x is equal to 35. Question number 2, same deal. 56 times the quantity x plus 1 is equal to 64 times x. Distribute in. Subtract. And x is equal to 7. A little mistake there, apologize. Question number 3, I'm going to do the same thing, cross multiplication. So 14 times 2x is equal to 7 times quantity 5x minus 5. Same old here. Subtract this, so we get that to be negative 7x is equal to negative 35. X is equal to 5. Right. As we move down, we start looking at our work with similarity and some of our similar triangles. If we look over on the right here, excuse me, on the left, we're going to match using our similarity statement if we need to. This one we really kind of see straightforward. 15 over 5 is equal to x over 3. 45 excuse me, is equal to 5x. X is equal to 9. Question number 5, 21 over x is equal to 18 over 9. And we cross multiply. 18x is equal to 21 times 9, and that is 189. And then x is equal to 10.5. Looking further down, problems 6 and 7. The best thing I can tell you to do on each of these is to use the similarity statement. A lot of times when we look at these problems, we do see that similar, or those similar triangles come out. And if we do see that, then that's great. Here we see this one. If not, use those similarity statements. We have AB, and we know that that's going to be similar to CE. So AB is x, CE is 2. We also see that BC is similar to ED. BC, x plus 4. ED is 5. At this point, it becomes a simple algebra problem. X is equal to 8/3. Question number 7, I think that is a little bit more important to look at that similarity statement. We don't have an AB, but we do have a BC. And we know BC is similar to ED. BC, from here all the way to here, is x plus 40. So, x plus 40. And we know that that is similar to ED, and we know ED to be 80. Then we look at AC. And that's similar to CD. AC, x minus 20. And CD, which is 40. At this point, we're just going to go through and do what we know what to do. 40x plus 40 is equal to 80, and x minus 20. So 40x plus 1600 is equal to 80x minus 1600. Doesn't matter which way we're going to move. I usually like to deal with positive coefficients. And move that over to 3200. And x is equal to 80. Now, again, I told you I like to work with positive coefficients. That's purely because of our work with second-order polynomials and factoring, the box method, and all that. If you move the other way, it would have worked just as well. And we'll look at the bottom two on this page. This is a scale factor problem. Remember that our formula for scale factor is just object 2, or side of object 2 over side of object 1. For number 8 here, side of object 2 is 24, and side of object 1 is 6. So reduces down to 4 over 1, or 4. Question number 9, same deal. Side of object 1 over, side of object 2 over side of object 1. Reduces down to 1/3. Right? Scale factors can be fractions. In fact, we know if something is getting smaller, then it's going to have a scale factor of something less than 1. It's actually a very important part of dilations when we start looking at that idea of enlarging or reducing. If we're reducing, we're having a scale factor of something less than 1. All right, let's look at the back page. And then we'll look at some proofs. All right, question number 10 said, are these two objects similar? If so, how? In this problem, we see that we've got our work with angle and angle, and then we have a shared angle right there. So we would say yes by angle, angle. Question number 5. Well, we're going to see we've got a set of sides, angles, sides. We can assume that this is side, angle, side, but before we get too far, we do need to check to see our ratios hold true. And so I'm going to take my smaller of the two sides and see if that works out with the smaller of the two sides. And 10 over 5 is, in fact, 16 over 8, which is 2 over 1. So I would say yes by side, angle, side. Question number 12 here. Even though we see 10 and 15 and 8 and 12 working together, the problem here is that we have angle, side, side. And we know that angle, side, side is not a valid methodology. And then 13. We have 3 sets of sides. And so we can assume that it might be side, side, side. But before we get too far, we do need to test it. So let's go through and do that. Remember, we match the smaller side with the smallest side. So the smallest side here is 3 and 4.5. Doesn't matter how I set this up. I'm going to do it that way. Could have done 4.5 over 3, would have been fine. Next set, 5 over 7.5. And then my last set, 7 over 10.5. If these all reduce down to the same common ratio, then it isn't a good method. Again, if you're bad with fractions, use the calculator. 3 divided by 4.5 will give us a fraction. Or excuse me, give us a decimal, which is 0.67. Right? If we go through and reduce, we can take 1.5 out of both of those, and we get 2/3. And in fact, we see that those are all the same. So we would say yes by side, side, side. That's the main part of the quiz. And what I'd like to do now is to take a look at the proofs. Now, the proofs should be fairly straightforward for us because these are ones that we did see. We have looked at these before. We've never actually gone through and done any of the direct work, but we have seen them before, so it should come fairly smoothly for us. All right. A couple things that we know. We know that the length of AB is equal to 7. The length of AC, or excuse me, CB, is 7. Length of BE is 9. And the length of CD is 18. We also know that angle AEB is congruent. Running out of space there. So angle ADC. Excuse me. Now, if we look at this, we might be tempted to look at side, angle, side and say, you know what? I've got a side, I've got sides and angles. But I can actually make this a lot easier for myself. Because in order for me to go through and prove side angle side, I'd actually have to find these angles here, which I could do, but I'd have to have the third angle theorem. But I do know, in fact, that this angle for this triangle and for this triangle are the same. So I've got this set of angles, this set of angles. There's my angle. So I have one of the angles written already here in my givens. I just need to do the next. I know that angle CAD is congruent to angle BAE. And the reason we can say that is via the reflexive property. Or if you wanted to, you could just say these are the same angles. Now, finish myself out. Just need to set up my similarity statement, excuse me. So I've got triangle CAD is similar to triangle BAE, and that is via the angle similarity postulate. All right, nice one. This other one's not bad. It is a little bit more difficult, but still not too bad on the whole spectrum of things. Let's take a look at that one. All right, so I've got some information here in my givens. Now I do probably need to add a given. I probably need to add a given here. I know something about this, but I also need to talk about the lengths of these. So I do need to say that the length of BA is 21.5, and I need to note that the length of BE is 43. So, statements. Well, I could probably start by talking about the fact that there's a 1-to-2 ratio here. And I know that if I have something to deal with these two sides, that would be good. That'd give me one set of sides. I can assume by the fact that I say AC bisects BD that I'm going to end up talking about these two sides. And then I've got something about these angles. So that's probably more than likely what I need. So let's first start with these sides. What I'm going to say is the length of BE over the length of BA, I write it sideways like this just because I got bad handwriting, is 2 to 1. Right? And my reason is just either the definition of ratios, or if you wanted to, you could just say division. All right, let's talk about this other set of sides. So, because AC bisects BD, I know that the length of BC is equal to the length of CD. Okay? And that's just a definition of a bisector. And I know that BD is equal to, and length of BD is equal to the length of BC plus the length of CD. That, of course, is just the segment addition postulate. So if I plugged in BC here, then I would say BD is equal to BC plus BC, which is equal to 2BC. So if I set up my ratio of BC to BD, I would notice that that is BC over 2BC. Oops, I think I did it upside down. That's all right. Is equal to 1/2. Right? And I can correct my mistake here. by just saying then that the ratio BD to BC is equal to 2/1. So let's look here. This was substitution. And here I have the same thing, definition of ratios. And then this is just division / reciprocal. Now, I'm getting to a place where I need to have some more information. I've got my sides. I need to talk about my angles. But actually, I can do this all in one step. Because BC bisects angle ABE, I can simply say that angle ABC is congruent to angle EBD. And that's just, again, by the definition of a bisector. So, I've got a set of sides, got another set of sides, the angle between them, I just had a side angle side. And my last step is to write my similarity statement. I have triangle ABC is similar to triangle EBD, and that is by the side angle side here. Now, interestingly, this proof was done in our two-column format. And we went through fairly straightforward. This is my little mistake here. We probably could have avoided some of that confusion by me writing this differently. Really, though, if you think and you go back through and listen to how I explained all this, we really probably could have written this as a paragraph proof. And it may have moved a little bit smoother than the way that we have done it in this method. Just one of those things to think about when you're setting up these proofs. If you can set it up this way, a lot of times it will make your life a little bit easier. Okay, there you go. Have a good rest of the weekend.